Linux Security Part 1. In this nugget, we're going to look at what you can use to secure your Linux system. We'll start by talking about NIS, which is the Network Information System, which enables you to share data securely over your local network. And then we'll talk about the Extended Internet Services daemon, which manages internet services on your computer. Let's get to work. All right, well, our first topic in this nugget is going to be NIS, the Network Information System. NIS is good for distributing information throughout a Linux network. The classic example is password information. Okay, so it would be nice that if there were multiple computers in some network that you logged into, it would be nice if your password was the same on all of those computers. When you change your password on one computer, it would be nice if it changed on all the other computers with the same command. Well, NIS allows you to do that as well as more. Okay, the NIS uses a standard client-server architecture. So the basic way it's set up is that each NIS domain has one master server that holds this shared information like the password file. Okay, then clients that are out there use NIS to get the information stored in the server's databases. And the databases that shared information in NIS are called maps. So now there can be more than one server. There's always one master server, and then there can also be slave servers. If you find your master server is just getting pounded with too much responsibility, then you can have slave servers to distribute the load amongst another computer. Okay, but we're going to, for our example in this nugget, we're just going to assume that we have one master server to set up. All right, so let's look at how to set up an NIS server. The first thing that you do is you set the NIS domain name. Now, the NIS domain name is not the same as the DNS domain name. Okay, think about IBM.com, for instance. In IBM.com, we're not going to need to share like password information on every single computer in the whole IBM.com network. Okay, it's probably sufficient to share password information amongst all the machines in some project or something. So typically, NIS domains are smaller than DNS domains. NIS domain names should be different than DNS domain names, even if the NIS domain encompasses the whole DNS domain, just for security reasons. You should always make sure the NIS domain name is separate or different than the DNS domain name. Once you've done that, then you configure and start the server daemon, which is called ypserv. Then you initialize the NIS maps, that shared information. You have to initialize that and create the files that are then going to be shared across the network. And then you start the NIS password daemon. Okay? Now let's talk about how to configure an NIS client. All right? The first thing you do again is you set the NIS domain name. And this should be the same domain name that you set for the server so that the client and the server can talk to each other. All right? Then you configure and start the NIS client daemon ypbind. All right, we're going to go over how to do this and how to configure a server on the Linux screen. I just wanted to give you these two slides as a reference point so you can come back and see where we are in the whole process. The other thing I wanted to mention is that you can see the client daemon name here is called ypbind. Back on the other slide, the server daemon was called ypserv. Okay, the configuration files are like ypsomething.conf. Everything starts with YP because when Sun Microsystems developed NIS, they used to call it Yellow Pages. And so all the commands had YP in them, right? But then they got sued or something by British Telecom, and they weren't allowed to use the name Yellow Pages for their service anymore. So they changed it to NIS, but since they had already deployed it and people got used to using it, all the command names and the configuration files and everything that started with YP sort of stuck around. Okay? So let's move out to the Linux screen now and go over how to configure an NIS server and client firsthand. All right, so step one is actually setting the NIS domain name, and the way that we do that is we use this command, NIS domain name, and then you give the name of your NIS domain. Okay, I'll just call it secret, for instance. All right, if you type that command without any parameters, it just prints out what your NIS domain name is. All right, so you can see now it's been set. Now, this information though will be lost when the system reboots. This is just a temporary setting of the NIS domain name, and if you want to set it permanently, then what you have to do is you have to edit a file in etc sysconfig, and the file is called network. This is the same file where you set your host name. You can see there's the host name setting there. If I go down, I say NIS domain equals secret, then that will set my NIS domain name every time I log into the system. So I'll save those changes, and that's step one. Now step 2 amounts to configuring and starting the server daemon. Okay, the configuring is done in a file in the etc directory, which is where we're at right now, and if we do a listing, there's a file here called ypserve.conf. Now out of the box, the defaults that are set in ypserve.conf are probably going to be okay for your installation, but if you want to learn more about ypserve.conf, what you can do is you can look at the man page for ypserve.conf, and it'll tell you how it's set up and the kinds of things that you can do inside of ypserve.conf. Okay, setting the domain, setting security features, things like that. Okay, so I'm just going to quit out of there. Another file that is good for security, that's important for having good security in your NIS system, you can learn about by looking at the man page for ypserve. Okay, the actual server daemon. If we page down here, we'll see right here. Okay, there's a file that's going to live in /var/yp, and the file is called securenets. Okay, and they show you what a sample securenets file might look like. Basically, what securenets contains is a net mask and an IP address, and that just limits what particular computers can connect to your NIS server, and it's going to limit that by what their IP address is. So this is going to prevent people from the outside world coming in and getting into your NIS server and doing things. Okay, so that's a good file to have around and set up for added security to NIS. Okay, so once we have configured NIS, once you're happy with the configuration, then what we need to do is we need to start the server daemon. Now before we start the server daemon, we're going to have to check and make sure another service is actually running. Okay, so let's look at the port map service. The port map service is what, the port mapper daemon is what runs remote procedure calls. Okay, and NIS uses remote procedure calls, which relies on the port map daemon. So we're going to check to make sure that's running, and here the output is that it is running. If that's not running, you would say service port map start. Okay, so now what we're going to do is we're going to say service ypserve start. Okay, and this is actually going to start the YP server services. Okay, and you can see it says okay, so now that service is started up, and that's all there is for step 2. Right now we have 2 more steps left. One is initializing the NIS maps. To initialize the NIS maps, what we do is we execute a command called user lib yp, yp init, and then what we do is we say -m, and that's going to create the maps. All right, so the m is indicating that we're creating the maps for the master server. Okay, so we do this, and it says here what we're going to do. At this point, we have to construct a list of the hosts which will run NIS servers. Nugget is in the list of the NIS server hosts. Let's continue to add the names for the other hosts. Okay, so all I'm going to do here is hit Control-D because I don't want any other servers in this list. Okay, so the current list looks like this. Yes, that's correct. And then it's saying we need a few minutes to build the databases or those maps. Okay, now Nugget has been set up as an NIS master server. You can run ypinit -s nugget on all of the slave servers. Okay, so if you are going to set up slave servers, there's a few extra steps that you're going to have to go through. Like I said, for this example, we're just assuming that we're setting up one master server. But just check out the manual page or check out a how-to on NIS to learn how to set up the slave servers, and it's not that much more work. It takes a couple extra entries in this particular command and a couple other commands or daemons that you need to start on the slave server so that the information on the master server is transferred to them in a timely fashion. Okay, so now once we've set that up, now what we need to do is step 4, which is starting the NIS password daemon. To do that, what we're going to do is we're going to say service, and then it's yp password daemon. Okay, so notice there's double P's, double S's, double D's. Okay, it's like Mississippi or something. All right, so we say there and we say start. Okay, and now it's starting the YP password service, and that's good. Okay, so now we've started the YP password service, and we've also started the YP server process, right? The actual server daemon. But the way that we started them was just by typing at the command line to start, right? If you want to start these every time that you that the system boots up, then what you need to do is you need to go to that Red Hat config services graphical user interface, and inside of there, you're going to be able to configure what services start at which run levels and so on. And if you go all the way down the bottom here, there's 2 things right here, YP password and YP serve. Okay, this YP daemon, this is the transfer daemon. This is what needs to be on the slave servers so that they will get the information from the master server every time something changes. Okay, but we're not going to install that because we're not dealing with slave servers. All right, so you need to make sure those two are started every time. Okay, so we're going to say save. Okay, and we'll just exit out of there. Since we've already started them, we don't need to start them right now. And so that's it for starting the NIS password daemon and getting it to start at all subsequent boots. All right, well now let's talk about configuring an NIS client. Now remember, the first step to configuring an NIS client is setting the NIS domain name for the client. And we do that in the exact same way that we set the NIS domain name for a server. Okay, so the next step is to configure and start the NIS client daemon. So to configure the client, you can see here we're in the etc directory. If I do a listing, there's a file down here called yp.conf. Okay, this is the configuration file for NIS clients. So what we can do is we can either edit that file by hand, and if you want help doing that, just check out the man page for yp.conf. Basically, what you need to put into yp.conf is the name of the server that is the NIS server for your domain. Okay, one thing we haven't talked about yet is that a client, an NIS client, can actually be part of many NIS domains. So for each domain that it's part of, you have to list the domain, what the server is for that domain, the IP address, that sort of stuff. Okay, and there's different formats that you can write it in, and they just list the formats in yp.conf. So that's one way to do it, edit yp.conf by hand. Another way to do it is to use this tool called authconfig. Okay, now authconfig, if this looks familiar to you, it's because it shows up in the installation process for Linux. And let's just go through how to configure this. All right, so here we can choose cache information. I'll hit a space bar, that puts a star into there. Caching information, what this means is that certain information that's retrieved from the server is going to be saved or cached, and then that's going to make subsequent NIS lookups a little bit faster. Okay, depending on what's going on. All right, so doing this will make subsequent NIS lookups faster. We'll do that. I'll hit tab, I'll go down here to use NIS, spacebar, and now these highlight over here. Okay, I'm going to have to tab over to there, and so now I write in domain. I called it the secret domain. The server, I would put in the server of my my NIS server that I'm a part of the domain of. Now, since I only have one computer here, this is a little bit screwy because I'm just going to write in nugget here so that we can actually start those processes. You would never normally run a server and a client on the same machine because they're already sharing the same password file and so on. So this is a little bit contrived, but what you would do here is just write in the server that is either the fully qualified domain name or the IP address of the server that is the NIS server for your domain. Okay, so then we go over here to next. I just skipped out. I skipped by it again. No, there we go. Okay, hit enter, and now it's saying the authentication configuration. Okay, so in here it's saying using shadow passwords, using MD5 passwords. I'm not going to mess with anything on this screen. I'm just going to say OK, and now out here you can see a few things happen when I exited authconfig. It stopped and started the port mapper. Remember, the port mapper has to be running for YP bind to be active. Okay, then it says binding to the NIS domain, and then it's stopping and starting the NSCD. This is the name server cache daemon, okay, the NIS cache daemon. And so it didn't stop it. The reason it failed there is because it wasn't running, and so it started it up because we enabled caching. All right, now remember that we want to make sure these services are actually started each time the system boots up. So if we go to Red Hat config services, not service, then we're going to get that screen again that talks about, you know, what you want to start automatically at run level 5 and so on. And if we go down here, one of the things that we want to start automatically is YP bind. Okay, and you can see that's already checked, and I think that was because authconfig set that up for us. Okay, if we go up here to NSCD, that's another one that's checked, and that's another thing that authconfig did for us. Okay, so authconfig's nice because it took care of some of those details of making sure that it starts up every time we boot into run level 5, and that's pretty much it for configuring an NIS client. Now, real quickly, let's just look at some of the things that NIS can do for us, okay? Some of the commands that we can use that'll show NIS is working. One of the first commands that we can type is ypwhich. Okay, and this will tell us what the name of the master NIS server is. Now remember, this is a contrived example where I'm running the server and the client both on this Nugget machine, but what this is printing out is the name of the NIS master server. Okay, so in reality, I'd set the server up on Nugget, I would go, set the client up on some other machine, and I'd run ypwhich on that other machine, and it would tell me that the master server is Nugget. Okay, so another thing I can do is say ypmatch, and I can say Annie password. Okay, now this is showing the password for Annie in encrypted form, her user number, ID number, and so on. Basically the entry from the password file that matched Annie. Okay, so this is telling me that this file is being shared and I'm able to access it from the client. That's another sign that NIS is working. Okay, let me exit out of here and go back to being the Perry user. I'm not the root user anymore. And let me just show you how I can change my password using NIS. So what I would do is I would type YP password. Okay, now it's saying changing NIS account information for Perry on Nugget. So it's saying that it's changing it on Nugget not because I'm logged into Nugget, but because Nugget is my master server. Okay, so when I type YP password from any client in that domain that Nugget runs, that secret domain, then it's going to change my password information on that master server. Okay, so let me type in my password. Now it's saying changing NIS password. Please type in the new one. Okay. Boom, boom, and now the NIS password has been changed on Nugget. Again, because it's been changed on Nugget because Nugget is the master server, not because Nugget is the machine I'm logged in on. Right? You have to forgive the example again. Right? The fact that I'm running the client and the server on the same machine. Okay, so this is the kind of stuff that tells you that NIS is working. You can use this to verify that NIS is working, and now you've set it up so that each time you log into the system, what's going to happen when you set up this domain correctly, every time you go to log into the system, you're actually your password information is being verified on the NIS master server. And the way that this works is you type in the plain text password on your local machine, whatever machine you're logging into. Okay, then that password is encrypted on that local machine. All right, and then the local machine will look to the server and say, hey, there's that string, there's the password string that I'm seeing, and then it will compare the two, and if they match, then it says, hey, you're authenticated, you can log in now. So your plain text password never traveled over the network, only the encrypted version of the password, and this is impossible to break, basically, right? So this is one of the things that NIS does well. All right, so that wraps up NIS for us. All right, well now let's talk about the Extended Internet Services daemon, which is known as ZynetD. Okay, let's just take a step back for a second and talk about how client and servers programs interact over the internet. Okay, so use FTP as an example. FTP has a server out there, and then there's an FTP client running, say, on our local machine. All right. Now the FTP client on our local machine, we ask that client to establish a connection to some FTP server. If we don't specify what port to establish that connection over, it's done over port 21 because that's the FTP port. We talked about those default ports back in the introductory videos. 23 was the default port for Telnet, and 80 was the default port for HTTP. Okay, so our client says to the FTP server, we're trying to communicate with you. It tries to do that communication over port 21. Then the server that's sitting on the other side at port 21 says, yes, okay, I can see you. Let's do this communication. And now they're sort of linked up, and now we can use FTP. All right, we can download files or upload files or do whatever we do with FTP. Okay, so what ZynetD does is it manages all those sorts of services. All right, all these internet services. And the way that it does it is there's a directory out there called /etc/zynetd.d. And each file in that directory specifies a particular service that ZynetD manages. All of those services are disabled by default. All right, so if we need to start up some service that's managed by ZynetD, we need to go in and enable that service. We did it the other day, a few nuggets ago, for FTP. All right, for FTP, we had to go into Etsy ZynetD/FTP and enable the FTP service. Okay, so that we could set up an FTP server on our machine. All right, what I want to do now is go out to the Linux screen, look through the Etsy ZynetD.d directory, and talk about some other ways to enable services that are managed by ZynetD. All right, well, we're already in the Etsy directory. Let's go down into the zinetd.d subdirectory and do a listing. And you can see all the different services that zinetd manages. Here's VSFTPD. That's the file that we messed with a few videos ago when we wanted to set up an FTP server. Here's the telnet file. That's going to control the telnet service. All right, so if we just look at the telnet file right now, you can see it says disable equals yes, just like it said for VSFTPD when we went into that file a few videos ago. Then that service said disable equals yes. We changed it to disable equals no, and so the double negative there, disable equals no, means that it's enabled. All right, and we could do the same for telnet. All right, we could go into this file, we could change that from disable yes equals to disable no, and then what we could do, remember, is we have to say service zinetd and then say reload there. Okay, and we would reload the zinetd service, which means zinetd would reread all of these files. It would see under telnet that it says disable equals no, and then telnet would be enabled on our system. All right. That's one way to go about things, editing that file by hand. Another thing that we can do, another way that we can do that, is we run check config, and we can say telnet on. All right? So if I do that, then what happens is, now let me cat out the telnet file again, you'll see it says disable equals no. And luckily it fit on the screen. You can see it said disable equals yes just 5 seconds ago, before I ran this command. Okay, this command not only goes in and changes this file, but it has zinetd reread all of those files in this zinetd.d directory. Okay, so this alone, this command alone, will actually turn on the telnet service, have zinetd reread the stuff, and so telnet is now enabled on our system, and I can show that to you by just saying telnet localhost. Okay, and then I can log in. I can say Perry, and then I can type the Perry password, and now I'm logged in as Perry on this machine. Okay, so I just used telnet, and I enabled it with that command. Okay, let me exit out of here, and now I'm back to being in the zinetd.d subdirectory. Okay, so that's one way that you can turn a service on. It's still useful, though, to go in and say, let's actually edit this file, telnet. Okay, there's still reasons to go in and edit this file if you want to change some of the other flags in here besides just the disable equals no. Okay, so we don't have to know what all of these different parameters mean. The user parameter tells you what username the server is running as. So this is saying if the telnet server is running on our machine, it's going to be running as root. This is the actual executable of the telnet server. This is what gets logged when there's a failure, and what gets logged is the user identification number. Okay, let's look at a couple other useful parameters that you can set in here. One of them is called only from. Okay, and no capitals there, just all lowercase. Only from, and then what you do here is you specify an IP address or a set of IP addresses that you're allowing access from. So we're saying we're allowing access to telnet. We've said disable equals no, but we're only going to allow access from these particular IP addresses. Then the way that you specify the IP addresses in here is in what's called CIDR notation, classless interdomain routing notation. All right, I don't think I've talked about this yet in any of the videos, so I'm just going to briefly mention it. Here's an example of CIDR notation. Maybe you've seen it before. So 192.168.0.0/24. What does this mean? All right, remember that an IP address, each one of these numbers here is really an 8-bit number. Binary digits, zeros and ones. There's 8 binary digits representing each one of the numbers in between the periods. Okay, so since there's 4 fields there, 8 bits per, there's 32 bits for an IP address. Okay, 32 binary digits for an IP address. All right, what the 24 is saying is that the first 24 bits, those 3 numbers right there, are fixed. And the last 8 bits are flexible. They can be anything. So what this is saying, the IP addresses that this is specifying is like 192.168.0.anything, 0.5, 0.53, 0.97, up to 0.255. Okay, so that's what this address format is this notation is specifying. That's the IP addresses it's specifying. There's another directive here that we can use that's called no access. So I can say no access. All right, and now I've turned this around. I'm saying yes, Telnet's enabled on my machine, and everybody in the world can access it except the machines with this particular format for their IP address. Okay, so those two are useful ways to restrict or enable access to some particular service. We're going to look at other ways in the next video, but for right now we're just going to do this. Okay, and these no access and only from fields, you can do that for any service that ZynetD manages. Any of those files in the zynetd.d subdirectory, you can use this particular setting to restrict or enable access. All right, well, it's time to wrap up our first nugget on Linux security. We started by talking about NIS, the Name Information System, and we showed how to set up NIS servers and clients to share data over a local network in a secure fashion. The example we used was passwords, and we showed that when you log into some client machine in this NIS domain, that your password is verified from the master server's password list without the plain text password ever traveling over the network. Okay, so people couldn't snoop and grab your password. Then we talked about the ZynetD, the Extended Internet Services daemon. All right, and this is responsible for managing all these various internet services like Telnet and FTP. And those services are the reason why hooking a computer up to the internet is inherently insecure, because all those services are insecure. So ZynetD gives us a way to manage those services in a somewhat cohesive or coherent fashion. They all have kind of the same configuration files in that zynetd.d subdirectory of etc that gives us a way to restrict access or allow access or disable the service altogether. Certainly the most secure computer is one that's not hooked up to the internet, or if it is hooked up to the internet, it has all of the possible services that you could get into it just completely disabled, okay? But sometimes you need some of that functionality, and ZynetD just gives us a way to manage those services in a cohesive way. All right, well, we'll have more on Linux security in the next nugget. Thanks for watching this nugget. I hope you found it informative.